Good morning, everyone, and welcome to our second Tech Talk. This is put on by the Engineering Technology Forum to support the educators in the two-year colleges teaching manufacturing and engineering technologies. So we're really excited to have you all here today. We'll do a little bit of housekeeping and then move quickly into our presentation about root cause analysis. So first of all, you all see that you have a control panel on the right, and there will be a couple polls coming up. So you'll see one of the menu items is a poll option. So you'll be able to go there. You'll see the polls come up. And then below that is a handout tab where the materials for this particular webinar are saved. You can download from that handout area. There's 3 handouts there. One with a tutorial, the PDF is the slides, and the Excel is the working template for what you're going to view today. So now I need to figure out how to go to the next slide. Sorry, folks, because I don't have the control right now. There we go. So I'm your host, Marilyn Barger. I'm the director of the Florida Advanced Technological Education Center, now part of the Florida Makes Network. And my co-host is Laura Sharp. She's from St. Petersburg College in Pinellas County, Florida, and is the program director for engineering, manufacturing, and building arts over there. So a little bit about FLATE as we've moved out of our NSF funding and to working with the Florida Makes Network. We are partially funded by the Florida Department of Education under their Perkins 5 State Leadership Grant Awards. So we appreciate them as a co-sponsor of these activities as well. Our vision in FLATE is to drive the world-class manufacturing workforce in our state, and we're excited to be continuing that as we've transitioned. For us, that means working for having the best curriculum. That might mean reform or just up-to-date curriculum to support manufacturing across the state in the high schools, the colleges, and the technical colleges. We work to support professional development for our educators at all those levels, STEM levels in the K-12 arena, and then very particular technical or pedagogical professional development for the post-secondary level, which is what we're doing today. And lastly, to have good, strong programs, we think it's important to have a lot of students enrolled in those to meet the workforce needs of the manufacturers around Florida. So we work to promote manufacturing and to change the perception, just a good, rewarding and high wage careers. So that's what we do in a nutshell. And this basically, we're going to do our introductions and today do our presentation about root cause analysis, look at some resources, have some questions, and talk about our next session. And now, Laura, I'll turn that over to you.
Thank you, Marilyn. And I apologize, everyone, that my camera can't be on at this time. So I have the pleasure of introducing our speaker today, Bill Mazurek. Bill is the president and managing director of Maztech and Associates, which is a continuous improvement consultant service that he started in 2015. He has held several senior leadership positions with Hillsborough County, ConMed, Bristol Myers Squibb, AT&T, and Westinghouse, with concentrations in manufacturing operations, service, new product development, business mergers and acquisitions, strategic planning, and project management. Bill holds degrees in industrial engineering technology and an MBA from University of Miami. He is also an adjunct at St. Petersburg College. And before we completely hand it off to Bill, we'd like to get a sense of our audience. So we're going to put up a couple of polls. The first one is we'd just like to get a sense of our audience and where you work. So we'll There we go. So go ahead and choose an answer. And we'll just count down. So 5, 4, 3, 2, 1. Let's see. All right, so the majority of our audience today is from manufacturing and related industries. We have someone from K-12, which is awesome, and then from higher ed. So welcome everyone, we're glad you're here. And I'm sure you'll find that this is informative all the way across. And our second poll will help us get an idea of how many of you use our main topic today. So our second poll is, do you use root cause analysis techniques in your work or teach it in your classes? Simple yes or no answer. Okay, so not too bad, 60-40 split. So that gives us an idea of where everyone's at. Either way, I know that you will probably learn something new today. I know I did when we first started working on this. So knowing that, I am going to hand it off to our speaker, Bill Mazurek.
Thank you, Laura. Good morning, everybody. And let me make sure I am functioning here. I don't know if I have the handoff yet.
Yeah, Amanda, can you switch presenters?
Are you ready? Can you see my screen now or no?
Yes, we can. We don't see the, oh, there's the PowerPoint.
Okay. So I wasn't 100% sure if it was going to be my PowerPoint or your PowerPoint. So let me get to right to here. Quantitative root cause analysis, everybody. Good morning again. I've used root cause analysis throughout my career in teaching and also in a professional capacity. And it's really interesting, you know, throughout my years until I really started developing more of a quantitative approach. And what I really mean by that is really creating the standard work around what the root cause analysis process is. Because too often in the past, literally the tools and the techniques are taught reasonably well, but they're all tool-based. I mean, if you're talking a fishbone diagram or a Ishikawa diagram, which are the same, it's trying to get to the root cause. I mean, everybody teaches that tool. And then people jump in with 5 whys and then they do problem solving and brainstorming, et cetera. But there's no really linkage to pull together all those tools as a system. And what I found over the years, I mean, it really is, you know, your output is as good as the facilitator doing the job for you. And if their interpretation is different, or if they cut corners here or there, then literally you get different outputs. And then you still measure it and you wonder why the improvement wasn't as significant as it could have been. And so what I've done over the years, I've tried to create not only the tools, but I wanted to do a standard work around the tools. This is how we approach the root cause analysis. And then I also wanted to go through a structured quantitative ranking because otherwise everything is equally weighted. So with that backdrop, I'm going to get started. And the talking points today, you know, I'm going to be talking about a problem statement and why that's important to the overall identification of the problem and striving for your goals. You know, the structured QC&E diagram, again, it's similar to the fishbone Ishikawa diagrams that we've talked through, but what's important about this one, it really drives that ranking again. It gives you the opportunity to do multi-voting and try to identify the vital causes. After that, there's a structured 5 why that I'm going to be going through, and then there's a risk priority number I actually bring into the 5 whys, and I'll explain that. We go through brainstorming, but once you get your solutions, though, you rank those solutions based on impact and difficulty of implementing the solution. And so literally you're looking for things that you can achieve versus a long-term project that may take you several years to achieve. And so that's important. Then identify actionable items and you develop your action plan. Then you create a control plan to measure the results to make sure you're sustaining your gain. So that's really the steps that I've gone through, that I've documented, that I've got my, there's a shared template that we're going to be giving you at the end of this thing as a link. Then plus there's some additional instructions how to use it. And there's actually a working example that I've also provided in that video that's not going to be covered today, but if you're interested, you can look at that as your leisure as we go forward. There's several acronyms that we're using, from cause and effect diagrams to 5 whys to risk priority numbers. They're in the presentation for your reference. I'm not going to cover them all in detail, but hopefully I won't be confusing you too much on that process if you're new to the subject matter. The deliverables, again, is going to be this presentation. There's going to be a template in Excel, and there's going to be 8 workbooks associated with the templates. You know, there's going to be a standard work definition, there's going to be project charters, all the way through to the things I just discussed. So every one of those tools I'll show you during this presentation, but they'll also be available to you after the presentation for you to use going forward. And then there's the video how to do it. And then plus there's a real life example. I filled out all the tools 1 through 8 with a real life example. And so you can actually see how I did the example in addition to the blank template that you'll have to use going forward. And you can either use on your job or you can just teach to it. But it's more of a systematic approach is what I'm getting at. Typically, root cause analysis, there's really 3 basic approaches when you apply it. Normally, there's a current problem that surfaces. Oh my gosh, there's a problem. What are we going to do with it? There's a new product design or re-engineering of a product that also potentially you could apply root cause and effect analysis to, and plus new processes or significantly changed processes. So every one of those are a separate topic area. Where we're going to zero in is the current problem. Something is broken, something is causing too much scrap, there's an issue that we're doing. So that's probably 70–80% of the world. You know, there's an issue and solve the problem, Bill. And so that's really what the current problem really kind of drives us through. The normal steps, again, the high level steps, again, define the problem, you data collect to confirm, you identify the root causes, and then potential causes, identify them, brainstorming, identify and implement and monitor. And there's steps associated with each one of these, but again, the current process, the way it's taught today, there's just tools out there for each one of those. I mean, people may downplay the problem solving or the project chartering, if you will, on the front end of it, how to identify the problem. Once you start getting into the causes, well, as long as you did a fishbone diagram and you get to the potential causes, you're fine. You know, but then how do you brainstorm solutions and so on? So this is kind of the normal steps that we go through. You identify the problem, you make sure it's aligned to your customer or business needs. What are the specific issues you observe? What is contributing to the overall problem? What happens if you don't tackle the problem right now? Is there a business impact? And that's usually shaken out during the problem set of the discussion. And detail the problems, problem statement, and identify the improvement goal. A lot of times, you know, again, what I've found that if you don't have a very succinct project charter that's defining what the goals are, you know, it's like Ford used to back years ago when they did their 0 defects or their 0 errors that they did for years and years, and that was more of an advertising slogan. But was 0 defects their absolute goal? Because again, it's very difficult to achieve 0 defects when you've got 27,000 parts going into an automobile, and potentially there may be variation on some of those parts. So it's really difficult. Now, maybe a 20% improvement, or there should be a specific goal related to them. Project, the charter itself, again, it goes through the statement, the scope and breadth. How far do you go with your problem statement? Again, current state, you may or may not be doing this, but what I find is important, are you trying to boil the ocean or you're trying to boil a cup of water for your tea? I mean, what is the breadth of the project that you're, the problem and the scope of the problem that you're trying to deal with? Impact, the objectives is the improvement goal. You got to be quantified. I want to show a 10% improvement in something, scrap, whatever it may be. If it's scrap reduction, the benefit is usually going to relate to some type of dollars. It's going to be a cycle time improvement. It's going to be less scrap. It's going to be less rework. There should be some dollars associated with it. How do you determine and measure the defect? It sounds simple, but again, you got to be consistent with the measurement. If 3 people can't walk away with the same measurement outputs and identify that as a defect, then potentially there could be a measuring systems analysis issue. And then it's got to be stated in a process that everyone would understand. So whatever that problem statement is and your improvements throughout this whole cycle, you got to make sure the defect is really identified, that anybody walking up to it, if you're hanging this on some type of review board, you should be able to pick it up and understand it without any explanation on it. That's really what I was trying to drive through. Confirm it. What is the problem state? If no data is available, you're going to have to collect some data to verify it, because again, is there a real problem there? And then the other thing, when you're identifying with the data, when did the problem occur? It should be time sensitive, because again, if you're living with this defect for years and years and years, that's one thing. But if something just happened, you can start zeroing when did the time occur, and then you can put a time bucket around that, if you will, and then look at potential changes that occurred around that time window. Customer, employee, stakeholders, spoken, unspoken problems, frustrations that may be related to the problem set. And is it a reoccurring problem? How current is the problem? Excuse me. And is there any historical data, past data, that actually supports that? Identify potential causes. Again, fishbone is typically the best way to identify that, and I'll show you a couple examples here in just a minute. What are the factors that the combination that lead to the problem? How many causes are there? And at this stage, you're not really thinking of solutions, you're just identifying potential causes. What was the causation of the problem? Involve your team, subject matter experts, and this is kind of the wild card. The team members itself that you're bringing in and the subject matter experts, they're the ones that you're really, you're trying to help you quantify how impactful the problem set is once you identify the causes. There's always some variation in there, because the team itself may rank something higher than what it actually is occurring. But with that said, though, that's part of that continuous improvement cycle. You can't look for perfection, but all you can do is hopefully get the right team together, get your subject matter experts, get the people building the product, and listen to their voices. And if you listen to their voices, normally they're going to point you in the correct direction, if you will. Fishbone, cause and effect, Ishikawa, they're all the same. And there's, going back a few years ago, was 4 M's. Now it's typically 6 M's everybody talks about. It's machines, methods, materials, Mother Nature, man is the operator, and the measurements that you're dealing with. Problem statement, and you're really looking at anytime, whatever that process is, the problem statement is, can any, is material causing your issue? Is the operator causing the potential issue? Is really what you're trying to drive through. The 6 M's, again, it's man, it's the people performing the job. The equipment and tools is machinery. Methods, that's the standard working instructions. The material is your input required for the process. That's the stuff coming into you. The measurement is the data input of the specific product. So these are your specifications, typically your measurement. And also the measurement is, what are you collecting in the process? What is critical for you to measure during it? And it gives you a feedback of a good or bad product. And the Mother Nature component of it is really the environment in which the machines and the operator is really working within. Is the place air conditioned? Is it high humidity? Is it a clean room or not? I mean, there's environmental type issues that may play to the success or failure of the product set that you're dealing with. Once you start grouping and prioritizing the causes, now you've identified the causes. The real issue is, you got to group it. And there's an affinity diagram that actually helps the grouping. So if you got 4 or 5 categories, you may be able to group it into one standard work category. And then by developing standard work, you're going to cover several of the functional areas that may be causes that may be contributed to the issue. Typically, the current fishbone diagrams and some of the weakness of it is that everything on that fishbone that was identified is equally weighted. And so somehow you have to prioritize what the most important issues are. There's not a lot of discussions on it. I mean, you look at, there are some people that go through multi-voting. I try to do multi-voting through my process experts. And that and as a result of that, the output of that steers me in the right direction. There's not a lot of information, or there's not a lot of teaching around that subject matter. They just get you to the fishbone diagram and to identify the causes. But not all causes are equally weighted, though. And so some causes are certainly more significant. So that's really what this multi-voting is trying to get you. The typical fishbone cause and effect diagram, this is the bad burger complaint. So there's several things could actually create causes. There's 16 type causes here. And if you kind of look at, it could be raw material. And so within raw material, you got not fresh and not as prescribed quality, not prescribed quality. That is what I'm talking in affinity. It's kind of grouping those under raw material. It's not fresh, staging, and so there's different areas. But again, like I said, each one of these is equally weighted. What you have to do as you start distilling through that, you have to create a 5 whys for every one of these. And so do you group these into areas that it's cooking, storage and cooking equipment? That could be an area. And then all you have to do is make sure poor maintenance is going to be one of those things you're going to be discussing within the 5 whys region. Otherwise, you're going to be doing 16 5 whys to really to do your due diligence if you're trying to resolve every causation that has been identified by the team. 5 whys, there's 2 different methods that are primarily out there. I use the one kind of to the left here. This 5 why worksheet is defect and causes. And then basically you're just asking, why did the defect occur? And then you keep on going down 5 levels. I've gone more than that if I need to, but usually by the time you get to that 5th level, you get a pretty good understanding of what that root cause is. And I'll show you an example in a few slides going forward. There's another one, you can write the cause down, and this is more of a PFMEA, process failure modes and effect analysis approach. That approach really zeroes in on the operator, the process, the methods, and the material. And normally when I'm doing a PFMEA, those are when you look at the effects and then you try to get into the cause identification through that, you're really dealing with an operator, a process, method, or material. These are really the 4 category areas that I typically deal with that you're trying to mitigate the error from occurring. Again, failure modes and effect analysis that's future errors that you're eliminating. The root cause analysis that we're dealing with, the problem already happened. And so that's why I usually use the 5 whys one. Some people like this one, but this is more going forward. This is trying to prevent a problem from occurring. This is typically used when the problem has occurred, and I'm trying to identify what that root cause is. This is one I did for the 5 whys for the cooking and poor maintenance equipment. Why was there poor maintenance? There was no ownership at Bill's Burgers to perform maintenance. And then why was there no ownership? No one was been assigned the task. And why was no one assigned the task? Mary, the supervisor, didn't know it was her responsibility. Why didn't Mary know it was her responsibility? Management, Mr. Big, never aligned the operational goals to include preventive maintenance responsibilities. Why wasn't it done? Because there was no standard work established for the supervisor to align the operational goals. So really the takeaway on this one was, okay, now there's no standard work for the supervisor. There's probably no standard work also to what preventive maintenance is, but at least identified a couple areas that maybe, the team now can start brainstorming solutions. What is it going to take to create the standard work? And then the way I do that, focus on elimination of the problem. Poke oaks, again, if you can prevent the problem from ever occurring, that's certainly a better choice. When I brainstorm my solutions, I try to stick to the 7 alternatives, and 7, what I mean by that is 7 solutions that I'm trying to brainstorm. And the reason I do that is by the time I get to that, the 5th, 6th, I mean, you start getting some pretty wild ideas by the time you get to the 6th or 7th idea. The reason I do that is that you want to build on some of those wild ideas because the whole team is there trying to come up with solutions. And if everybody's presenting their ideas and all of a sudden, oh, I didn't think about that. So what if we add this one to this one? All of a sudden now you come up with an 8th idea. And you just want to exhaust as many ideas as you possibly can. And I find the 7 seems to be the magic bullet for me when I do this. The way I do it, I just, everybody works on their own ideas. They stick it on, you can put a small group together, a couple people, or you can just do individually. And then you put it on Post-it notes, and then basically we hang them on a board, and then we kind of start combining those ideas together. Everybody presents their ideas. Then usually after an hour session or so, you end up with a pretty meaningful list of potential solutions. Then again, with those solutions though, then this is where the education, the breakdown occurs. Typically now, what do you do with those solutions? So you got to rank them based on impact or effort. Or there's this PACE prioritizing chart also that you kind of stick the stickies in the top sections and you kind of put those priorities, actions, or you want to consider those. I like to do effort and impact because I rank them 1 through 9. And then based on the ranking score, it actually gives you an area, a category where to actually put the item, and then it gives you a clear indication, should I work on this item or not? My spreadsheets that I'll show you just in a minute, there's an automated way to do that, and it gives you some color coordination that it's pretty straightforward for the team as an output to know what they should be working on. Then implement the change. So if I'm, like this first one would be create standard work, and Marilyn's going to be doing that. Her due date is March 12th. The start date is today. Completion date is going to be determined because it's not complete yet. And then deliverables are going to be daily, weekly, monthly standard work for the preventive maintenance. And it is assigned, and that was one of the quick wins. That was number 3 on this grouping. And then you monitor the results to make sure that you're sustaining the gains. If you're not, then you're back into this plan, do, study, and act routine that you're going to continue driving those improvement goals. So that's really what the process is. Weaknesses, I'm going to talk weaknesses and strengths briefly here. So the strengths of the current process, it's tool-based though, and it's proven, it's easy to understand, the Ishikawa and the 5 whys, etc. Ishikawa diagrams have been used for over 60 years, and the 5 whys has got 45 years of kind of history on it. It's been taught, every engineering class I think I've taken throughout the years, there's always some type of Ishikawa diagram referenced or taught, but there's some definite weaknesses to the overall process. Tool-based, it's not bad, but it's meant up to the facilitator to actually bridge that. Weaknesses, it's tool-based. It could be applied differently. The output results can vary. So it's really based on the team or the facilitator. I'm not so worried about the team, I'm worried about the facilitator. If we skip steps on that, if we didn't rank out properly the fishbone, then all of a sudden you're trying to deal with everything versus a handful. Identifying the true cause. It's really identifying the expertise of the facilitator and really asking those questions when you're going through your 5 whys. Solutions may or may not be selected on the impact. So once you got your solutions, it's that impact difficulty. I mean, how difficult it is to install, and then a lot of times labor, design, and cost may not be incorporated into that. How long does it take us to get to it? And then the 5 whys, the other thing we've got to be careful with, this go-see philosophy. Once the 5 whys is done, and it's gotta pass the smell test. Is that really the root cause? And it's getting people that may not be involved in the team discussion just to really start asking, questioning, go out to the process and kick the tires, if you will, to make sure that it's giving you the details that you're looking for. Your best practice, and this is what I'm going to be outlining, is really creating standard work for the process. I just mapped out there was 8 or 9 steps. What does that standard work look like? After you got the standard work, what are the quantitative steps? What is that ranking, the multi-voting that should be not subjective? That should be just, this is my standard, this is the way I'm always going to do it. If we always teach it this way, people will grab onto it, and I know we will get better results. The nice thing about that, then once you got standard work, then you can start memorializing, the results. So if you got future Kaizen projects, if something also fails on a different line or the same line, it starts repeating itself, you've got a good set of standard work and some documentation to support that. Yeah, we worked on that project a year ago. Let's pull out the data, let's pull out the fishbone, let's find out who was on the team, let's figure out what happened then, and then why did it repeat itself now? So you don't have to start anew a lot of times, you can keep on building from that process. And the best practices. Were we gonna do I'm not sure if we were gonna do another question. Were we gonna do a question now?
I think we're just going to stop and ask if there were questions. If
Okay.
anyone had any questions.
Thank you, Mayor. Yeah, so up to this point, before I get into the new quantitative approach, any questions that anybody has at this point in time?
You can write your questions into the question part of the dashboard
Thank you.
Or in the chat.
or in the chat. Yep.
Okay.
And I'll keep on going, and I'll look for, if any questions pop up, I'll certainly hold off then. So what I do, I have a standard work process that I deal with. It's easy for me to teach it. It's easy for me, and this is from an education standpoint. This is from a department head type standpoint. If I'm walking through and said, this is the expectation, guys, I'm gonna, this is my root cause analysis process. I want to do a problem statement. I want to identify, the first step into it, I'm going to do my charter. Then I'm going to do my QC&E matrix. Then I'm going to do my multi-voting. Then I'm going to look at my top quartiles or a Pareto analysis, and I'll show you that in a second. Then I'm going to break from this, becomes my 5 whys. Then after I identify my 5 whys to get to the root cause, then I'm going to do brainstorming. Then I'm going to do my impact difficulty matrix. Then I'm going to do my project plan. Then I'm going to monitor. I'm going to actually create a control plan to make sure I'm monitoring the process correctly. If I do these 8 steps consistently on every project that I'm doing for every root cause analysis, it doesn't take that long. I mean, don't get caught up into the time, because I can usually knock these things out in 4 to 8 hours. I mean, it doesn't take that long. And it depends how big the issue is. If you can knock out the potential, this is the solution, how long does it take the solution? It may take a little bit longer to implement, but it's identifying what that root cause is. It doesn't take a long time. The first one may take to get comfortable with the worksheets, et cetera, but after you get rolling on it, it's relatively fast. It really, really is. Again, charter, you'll see a charter very similar to this into the handouts. And it's just going to be the problem statement, improvement goals and targets. The gains need to be confirmed. And then you're going to, what is that defect definition? You're going to have to define that in the charter. It's not a lot, but then there's usually an approval of the charter. So this is good. Get a team together and make something happen. The first thing you're going to look at, so after you go through, I think this is the second workbook into it. So when you look at the attachment, this is one of the workbooks. So this is the nice thing about that, all this stuff is going to be linked for you. So this is going to be a blank template. You just have to type in what the problem set is, and then all these E0s to M's. So M is for method, E is for equipment, O is for operator, etc. So I broke this down as an example. But the template you've got has got 10 spots. You can insert more if you need to, but all you have to do when you do the brainstorming, just type in what these are: flawed recipe, recipe not being followed, no standard work defined, etc. And so by just defining these, then the very next slide over is it's going to be populated. So this is the very next one. This is going to give you the quantitative side of it. So this section of it comes in directly from your fishbone. So by typing this in, then as soon as this is completed, everybody's done brainstorming, then you've got everything populated into your quantitative ranking multi-voting template. First thing I do is I go through and I put the attendees down. So who are your subject matter experts? I just type their names in: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 5, 8, 7. If you get more than 10 people, it gets pretty confusing, to be quite honest with you. I try to keep it to ideally 8, 7, 8, 6 people. If it gets more than 8 or 9 or 10, I have a tendency of breaking this off into 2 groups. Same problem set, and you're going to go off in 2 different areas and kind of do your own brainstorm and then come back together again. But so when I look at the definition of how to get to this ranking, so now they got their names down. So if I've got 3 in this first categories, I divide this 3 by 2, you end up with 1.5, so you round up to 2, so everybody gets 2 votes. You don't have to necessarily take all the votes, but literally you attendee 1, what do you think are the top 2 issues or the top issue? So if you want to put a 2 there versus a 1, yeah, it's no recipe. That's my number 1 issue. So you just kind of tick off where they want to put their votes. And you do that for each category, all the way down through the categories. And then all of a sudden, and then what's happening on the right-hand side of it, this stuff is tallying up by itself. And this is based on quartiles. So this is giving you the top 25% quartile is the vital few. And then the next grouping is the useful many. And so you have to decide, do I want to just focus on the vital few? If there's 2, 4, 6, 8, 5 whys that you have to do for each one of those, unless there's some grouping going on there. But so you'd have 5 whys and 5 sets of problems that you would have to identify based on that one. So you're taking off these 19 items and you're breaking it down into the top 25% is 8 items. If you want to do the top 50%, you can certainly bring in the useful many. I have a tendency of just doing the vital few. And then, so that's the one workbook. The very next workbook into the process, some people still like to use Pareto charts. And so I've given you an option to do the Pareto chart. So everything automatically is linked and pulled in. The only thing you have to do is a sorting, and the sorting varies, there's some explanation and some diagrams how to do that. But the Pareto chart, you literally, any Pareto chart says roughly 80% of the consequences come from 20% of the causes. And so I can change off this cutoff point here. That's the only thing I have to just type in this particular spreadsheet. By typing 50% and I say, where were the top 50% of the items? Well, there's 2, 4, 5, 6, 7 items are the top 50%. If I want to do 20%, then I'd probably have the only 2 items. Let's see, 20, it'd probably be just 2 items, I guess it would be. And so that's the only thing I have to type in for this particular one and then do a sorting. If you're okay with just going with the vital few, there's no calculation, so nothing you have to do. All you have to do is, again, put the names in, put a 1 or 2 if you're up to 2 votes, whatever, and just categorize those. And it gives you the maximum, it gives you minimum range, and it gives you what the automatic categories are calculated, and it tells you what the vital few is that you have to do. So it takes some of that away from the team just based on multi-voting. And then if I'm reviewing this after the event has occurred or whoever did the problem solving, every one of these vital few should have a 5 whys, unless again they were grouped together, and you should be able to show the grouping. I grouped M1 and 02 because they were very similar. They didn't have standard work. So the 5 whys, again, once you get to the root cause, So this is the one that was happened before I reviewed it. Now I just want to show you the new template. The new template is still going to give you the first 1 through 5th Ys. It's going to let you type in the same exact information. The only thing I did differently though on this one, you've got this other category here called prevention. And so you don't necessarily have to prevent each one of these, but usually I'm looking for why wasn't it prevented at that very last step? If I know there was no standard work, why wasn't it prevented? Well, there was no goals established. That's one of the reasons. The other thing I do, this risk priority number, I put severity occurrence detection on the bottom of it. And this just gives me a scale of how important this one is compared. So if I had five Ys, if I was, certainly I'm going to take the highest RPN number and work that first, second, third, fourth, fifth. This is the most significant, and it says the higher the number, it's causing me the greatest potential failure mechanism. And where do I come up with these scores? So literally so this is also on the charts and the templates I've given you. So severity, I'm looking at, so I'm ranking it at 8. I said it was very high. The only thing you got to be careful with severity, once you establish severity, typically you don't change severity unless there is a process or something significantly changed. You're going to re-engineer the whole process, then the severity could change. But normally the severity stays the same. When I'm mitigating, all I can mitigate is the occurrence or the detection. How often does it occur? And how am I detecting the problem? So if I initially ranked this as 8, 5, and 10, so I said 8 was very high, 5, I said, okay, it was a low occurrence, and it was really a 3 sigma level, 1 in 400, or DPM of 6,210. So it gives me that indication of how many defects per million occurrences is it happening. How often does the problem occur? And detection, and this particular one, this was a standard work. I'm not detecting it at all because it's very high. It's uncertain. I could have, there's no way of detecting it because nothing's in place to detect it today. So that's how it got to very high. So when you do the math on it, you take severity times occurrence times detection equals the RPN number. The math itself on this sheet, if I go back one, this happens automatically by just plugging in these numbers. It extracts this number for you. So all you have to do is you're really filling out this. The template, this is blued out. You're looking at that last one here in the red indicator, why it wasn't prevented, just to give you a little bit more information. And brainstorming solutions, I'm just going to talk to them. So now that you've got your cause identified, you've got the root cause of the problem. Now you bring the root cause into the potential solutions. So what solutions could I do to actually shore up the standard work? And if you look like 7, 8, and 9, these are no preventive maintenance. So I'm going to do something daily, weekly, monthly. I want to do something here. I want to create some preventive maintenance from OEMs. So internal, external, I want to create some preventive maintenance schedules. I'm going to align the senior management goals. So these were just solutions. We were trying to come up with the cause. This cause is right off the initial spreadsheet that we had. This was E2. And so I just bring that forward and just describe it. But the nice thing with the template though, by just typing in whatever numbers I'm typing in, it's going to either give you a green indicator, a yellow, or a red. So instantly I know based on that ranking, and there's a scale there, 1 through 10, 1 through 9, I mean. And so based on that scale, you're going to rank it. It's going to give you a score, and it's going to tell you where that score is. The next slide is going to give you a little bit more indication. So I'm pulling in, these are my solutions. And what you're really looking for, like number 3 here, index, this is this solution, it's a 9.2. So this was a 9.2. So the difficulty was a 2, and it was a 9. So it's going to be up in this category. So that's why both of these are green. So really what you're looking for, anything in the green is a priority to complete, to solve, hopefully to eliminate the problem. We're ranking it high. It's giving us a good indicator. The yellows, you may consider it if you can knock out all the green ones. My priorities are knocking out the green ones first, and then I'm going to prioritize those, how I'm going to do them based on the risk priority number. The higher the number, that's the first one I'm going to start knocking out. because once you can start knocking them out, you're going to start improving instantly. If it's in the red, it still may be a good idea, but you may want to eliminate it. You know, buying new equipment, replacing freezers, that's pretty expensive, and it may not give you the benefit that you're looking for. And so that's how that works. Then once I get through that process, then I list it. This is another template you got. What are my activities? So these create standard work. This was the Maryland. So I'm going to do it, and I got a due date. If I elect to do if you're into the this risk priority number, which I do, I put a pre-number. Then after I do the standard work implementation and train everybody, then I go back and I reevaluate that. Again, severity stays the same. I'm looking at the occurrence and detection component of that. And based on those two components, I'm saying, what does that number look like? And then hopefully that's going to be, you're going to show a significant improvement, hopefully, on that one. And then the last thing I do is my control plan. And again, what are you measuring? The type of data. The target performance comes right from your objective. This is my target, that right from your charter. I'm looking for a certain improvement. That target improvement should link directly back to your charter. And so if I'm looking at somebody that's prepared a control plan, go back to your charter, look at it to make sure that these measurements are in line with that. Sometimes you have to create new measurements because actually the measurements may not be aligned perfectly. And then the guideline itself, and then we're just wrapping up here. So that's the template side of it. This is what I always do. I follow my standard work. And if you don't like my standard work, create your own. But it's important to create standard work steps. I do these 8 steps religiously. These are my 8 steps. I engage the subject matter experts into when I'm doing the process. If I can't get your undivided attention for 4 hours, 2 4-hour sessions, something's wrong. I need the operators, technicians, whoever the professionals are that should know about the product. Then you need to confirm the problem. You know, and this could be a process map, this could be your SIPOC, this could be walking, doing the gimbal walks, etc. Understanding the birth of the problem. Where did it happen? How often? Data, and what the timing of the problem is. You know, the Japanese are big on this. Where did the birth of the problem? Where did the problem and when did it occur? The other thing you got to be a little careful with, and identifying causes of variability. There's a lot of statistical information out there that talks about special causes and common causes. And really the problem, anytime you get a root cause analysis, you know, you don't know if it's special or common cause. You know, a lot of times your common causes, I mean, you've got everything is, it's already, you've got tons of historical data. It's following a normal distribution curve. Special causes are these oddball things that happen every now and then that are outside of the normal. I fell asleep, I didn't come back from break on time, whatever it may be, it may have caused something different. But the reason I'm spending a little time on this, you know, the variability, you kind of got to throw both of those out, because if there's a problem and you have to resolve it, don't get caught up in the special or common causes. I mean, the historical data is there, but you don't necessarily have to prove that the data is normalized at this point in time. All you're trying to do is identify something that happened, because if it's significant to pull a team together, it's a nuisance for management. It's a nuisance for the business. And so don't get caught up in the special and common causes on that one. You're just trying to understand where the variability is. A lot of times the Japanese, when it comes to common cause, they've got it nailed down, be honest with you, because they have standard work for everything. And so when they talk, you know, walking their gimbas, and they talk about andon lights and things like that, it's so refined, their processes, that any little hiccup, they can shut the line down and they can usually resolve it relatively quick. The problem with most industries, small, medium, and large, you don't have that standard work sophistication throughout the whole corporation, throughout every step. And as a result of that, you got a little bit more opportunities for variation to creep into it, common and special cause. And then the countermeasures, this is prevention, elimination, and airproofing. Again, airproofing is certainly the best solution you can do if you can eliminate that problem from ever occurring. But that may take a redesign, that may take some other pokey-okes or fixturing to get incorporated into the design. But that's certainly the best way to do it. But sustaining those gain in measurement is really the key. So this is kind of where I started the process. These are the 8 steps again: problem statement, construct QC&E diagram, multivoting, structured multivoting, decide if you want to use quartiles or Pareto. I always use quartiles and I do the top 25%, but you've got 2 different options there. Construct the 5 whys for each one of those that you've identified. Brainstorm the solutions, just freewheeling brainstorming. Then once you're done with the brainstorming, then you're going to rank those based on impact and difficulty. Impact in solving the problem, difficulty in implementing it, the solution. Then you're going to identify those as actionable items. Then you're going to develop a control plan to really monitor the results going forward. That's really what your key is. The standard work, you'll see it. This is kind of the pictorial of my standard work. I've got this nice flow chart too, 1 through 8, but these are kind of the areas. And if you look at the one I've got posted, I've actually up in the right-hand section of it, I've got the workbooks associated with each one of these. So this is, again, problem statement. You've got your cause and effect analysis. You've got your prioritizing of the vital few. You're going to take those vital few, you're going to take those into 5 whys to get to your root cause analysis. I'm going to sprinkle in an RPN number to make sure I can rank those based on importance. I'm going to take those items into solutions. I'm going to dial in my 1 through 9 on each one of these. This is impact and difficulty to implement the solution. It's going to give me a green, yellow, or red indicator. Green means I'm going. And then I'm going to take those green projects based on, again, referring back to the risk priority number and that solution. Then I'm going to rank those into a problem implementation plan. I'm going to implement it. And once I implement it, I'm going to do my pre and post. You can see it on here, pre and post RPNs. And then I'm going to monitor the results and rock and roll. So that is the details behind it. And I think I'm 6 minutes ahead of schedule, but probably 5 minutes late because we wanted 15 minutes for questions and answers. So with this one, I'm going to turn it back.
Thank you so much, Bill. That was pretty awesome. I'm checking to see if Laura usually does the Q&A. Laura, did you get reconnected? She sent a message that she got kicked out. I don't hear her, so I'll just push on. So Amanda, we do have at least one poll. We thought we'd check in to see. So can you do the poll number 3, which we missed a while back? We just wanted to check to see if you use or teach fish bones. That was one of the techniques we used.
Yeah.
We went through during the presentation, just one of many techniques. So everybody can answer those. And there we go. Got the, oops. Oh, look at that, 50-50. How about that? It's a great tool for organizing your problems and your issues without trying to just bulldozing your way in and fixing it ahead of time. And so now we're just going to open up for questions to anyone. Has any questions? I'll ask my colleagues to see if they see any in there. Daniele or Amanda, you see any questions? Nobody has any questions for us today?
I don't see any questions.
I don't see any.
Okay. All right. Well, we'll do our last poll in just a moment, but I want to remind everyone that we do have another session, not next month, but in April, and we'll have Mike Ennis from he was a Florida Makes Business advisor, talking to us about OSHA applications for manufacturing. Okay, so hopefully you'll join us. That's 2 months from now, not next month, because we'll be actually having the Engineering Technology Forum in March. So think about that, get it on your calendar, and there's a link to register right there on this PowerPoint. And now, can you put the poll up, the last poll up, Amanda? So now we want to know if you learned something that will help you with your work or with your teaching of this topic or other topics in manufacturing. So let's get some quick quick responses. Oh, I think we're done already. And have a nice 100%. Can you show the answers? There we go. Look at that. Great work, Bill. Really great presentation.
Well, thank you, Marilyn, and my contact information's out there too, everybody. So I mean, I've also done I've got an example, and I've did another video of actually how to do the filling out the template in detail. There's a YouTube video that it's going to be attached as one of the attachments, and it takes about a half an hour to get through it, but there's about 15 minutes of it at the front end. It takes step by step through the template. And then the other 15 minutes, it actually shows a real life example that I have actually populated throughout the process. And if you're really serious about teaching it or utilizing it, I would really encourage you to go through that video first. If there's any questions, don't hesitate to reach out for me. My email is there, my website's there. Just reach out for me, give me an email. We'll set up a time. I will do a Zoom meeting with you. I will do Zoom training if you want training, a little bit more deeper dive. I can actually walk through the template, but I'm really just trying to depart the information onto you, because I think this is one of those subject matters that are near and dear to my heart, and it really, if you do it well, you can get good results, consistent, good results. If you do it poorly, then people just kind of, it's up to the facilitator then. And so you need to take that out of the facilitator's hands and just make sure there's standard work to follow. So I'm here for you if you need me. So that's my last parting word. So thank you much, guys.
Okay, thank you, Bill. Thanks for that generous offer. I'm sure some of the folks out there might take you up on explaining a little bit more when they have their own questions after
using it. Yep, you're right. Yep.
Dipping into the template, the spreadsheet template that you've provided for everyone today. So we really appreciate those tools, and thanks everyone for joining. We're just about time to go. A couple minutes early. I'll give back to everyone, and have an awesome weekend. And we'll see you back here in a couple months.